What if I told you the mind you're about to see isn't alive, yet it can learn, predict, and sometimes surprise us? That's artificial intelligence. Not a soul in a server, but math in motion. Picture this: a semi-transparent head, a web of glowing pathways for a brain. Each point is a neuron, just a tiny calculator. It takes numbers in, multiplies by weights, adds a bias, and decides how much to light up. One neuron is boring. Millions layered and connected? That's where the magic, the math, happens. How does it learn? We show it examples, images. We show it examples, sentences. We show it examples, sounds. And we tell it how wrong it is. That wrongness is the loss. Then comes back propagation. A clever way to push blame through the network so each weight nudges in the right direction. Gradient descent is the rule. Step downhill on the loss landscape until mistakes are as small as we can get them. It's like teaching by millions of tiny, warmer, colder hints. Those holographic panels around the brain, code, formulas, datasets, are the world it learns from. Supervised learning, labeled answers. Unsupervised, patterns without labels. Reinforcement, try, get a reward, try again, like teaching a robot dog not to eat the sofa. Mostly successful. If you've heard of Transformers, here's the gist. Attention. Instead of reading every word equally, the model learns what to focus on. The bank by the river and the bank with interest share a word, but attention spots the clues that separate them. That's how modern AI handles language, code, images, even video. Inside, vectors, long lists of numbers, encode meaning. Embeddings put similar ideas close together. Cat. Embeddings put similar ideas close together. Kitten. Embeddings put similar ideas close together, not toaster. During training, weights shift so those distances capture useful structure. During inference, the moment you ask a question, the network runs a cascade of matrix math to produce the most likely next output. It feels fluent because the statistics got really good. Zoom out. Robotic arms adjust glowing controls. Interfaces for actions. Models don't just recognize, they decide. But they don't understand like humans. They optimize. Give them the wrong objective and they'll happily ace the test while missing the point. We call that misalignment. The warm golden flares? That's learning. Weights settling into patterns. The cool blues and purples? Compute at scale. GPUs and server towers humming away. The subtle drift of particles? That's noise, randomness, exploration. Sometimes the spark that finds a better idea. So, what is AI? A stack of algorithms, mountains of data, and oceans of compute that mimic parts of cognition, perception, prediction, planning, without being human. It's powerful, fallible, and profoundly literal. If you ask it for a joke, it won't laugh, but it might write one. And how does it work? Not by magic, by gradients, attention, and a lot of practice. The mystery gives way to clarity. Numbers in, patterns form, decisions emerge. The awe? That's on us, because we built a machine that learns.